Hey guys, Mrs. DeBest here, and I just want to talk with you guys a little bit about probability. I hope that you were able to get your materials for what we're going to be doing next. So probability is really fun to study. There are a lot of different numbers that go along with probability, but some of them that we're most familiar with would be like the chances or the odds or the likelihood of something happening. So some examples of probability in everyday life. So you've probably seen these before. These are the Harry Potter jelly beans, and they have those disgusting flavors, and you just never know which one you're going to get, like the one that tastes like vomit or marshmallow. I'm not really even sure what the vomit one is, but this would be an example of probability, like what is the chances you're going to get one that tastes disgusting, right? Here's another example of probability in everyday life. So you probably recognize something like this. Maybe you've got one of these or a sibling has. It's just a little plastic toy, and usually what you can see before you see the toy is the packaging, right? Here's one with Peppa Pig, and it's all these different pigs on it. And you look and you're like, oh, I really want this one, or I want that one. And what are the chances you're going to get the one that you want, right? This little guy's all not put together, but this one is. So I'm going to use this one for my example. So if you really wanted the construction worker Peppa Pig, then you'd be happy to get this one. If you didn't want the Peppa Pig and you wanted one of the other ones on this sheet, then you're not so happy with that. But we can actually do some math to figure out how many people are actually going to get the Peppa Pig that they want. Another example of probability, like a lottery ticket. These are the scratch-off instant winner lottery tickets. And you take a coin and you scratch it off, and it's going to tell you what your likelihood of actually winning is. And it's right on the back. They have to print them right on the back. So this one has a overall odds 1 in 4.57. So I guess that's really not too bad when we're talking about odds. All right, so another one that you may have heard of before, where people take a standard deck of cards. You've got 52 cards in your deck. Here we go. You got 4 suits and 13 cards for each suit, and you play card games like War, Go Fish. There's a lot of other ones, Michigan Euchre maybe, and some people will say, well, it's all in the cards. You just, it's not up to them. They can't cheat you. It's just how the cards, how they play, right? Another example of probability is a coin. So you've probably tossed a coin before to figure out who's going to go first or second. And one person will say heads or tails. You call it. And then when you flip the coin, if you had said heads, then you actually would get that one, because that's what came up is heads. So here are some examples of just everyday life. Another one would be fortune cookies. So when you get a fortune cookie, you crack it open. You've probably done this before. A lot of times at the very bottom, it'll say your lucky numbers, right? So this one has several lucky numbers, 9, 20, 3, 35, 44, 22. Supposedly those are your lucky numbers. But really, is this true, honest, I guess, luck? Well, it's all in your perspective, I would have to say. So how you want to interpret it. Some other examples of everyday life where we use statistics and probability would be the chance of having a boy versus a girl when you have children. And the likelihood of having a girl is a little bit less than having a boy. You're more likely to have a boy. So girls beat the odds, of course. In medicine and in health, we look at probability of different, like the vaccines that are working. You have a probability of 95% it's going to take care of your problem. Or what about that 5% that it doesn't, right? That's what we always question. Some other examples would be in sports. They use statistics all the time in sports, especially baseball, but they do it in every single sport to figure out exactly how this player performs, or what you need to score in order to win the game, that type of thing. We use it in our homework and our classwork for our grades all the time. It's just a little bit more convenient now because we have computer programs and apps that do the work for us, so we don't have to do as much of that by hand. So these are just some examples of probability. So if you flip a coin, you have a one out of 2 chance of actually getting heads or tails, right? We could write that as a decimal. It's 0.5. But we usually hear these as a percent, like 50%. So you have 50% of getting heads or 50% of getting tails, right? So for probability, we can use those 3 forms. There's another form, but it's usually used for odds, and that would be when we write it like this. We'd say like we have a 1 to 5 odd, or 1 in 5 chance. So for what we're going to be doing for this chapter, we're going to be focusing more on percents and fractions. And we're actually going to start off with fractions and then just convert those over to percents. So let's talk about a couple different types of probability. There are 2 main types. There's theoretical probability and there's experimental probability. And within those, there are other probabilities that we can discuss, but those are the 2 main. So theoretical, we usually write as a ratio or a fraction, and we're looking at what are the favorable outcomes versus the total number of possible outcomes. So another example I could use would be a die, right? So most people have your standard 6-sided die at home, right? So a theoretical probability example using a die. It's got 6 sides, and each side has a number, 1 through 6. And if I asked you what's the theoretical probability of rolling a 6, you would look at how many 6s there are on the die. Well, this die has 1 6, and there are 6 sides, so 1 over 6. What's the theoretical probability of getting a 3 when you roll the die? That would be 1 out of 6, because there's only one side that has a 3, and there are 6 sides. So that's theoretical probability. So we use that as like our base for information when we're trying to determine a probability of something else happening. Okay, so we go with theoretical. Now, how do we come up with a theoretical? Well, we actually had to do the experimental first. So we didn't do it first, but for rolling a die, but we have done it experimental data or probability first, and that's how we were able to come up with some more average probabilities. So if I compared theoretical with experimental would be I take a die, I roll it 50 times, and I record what number comes up every time for 50 times. And we would use tally marks. So you guys remember what tally marks are. So let's say I was running an experiment for this. I would want to make sure that I organize my data so it would be really easy for me to read it and interpret it, because we want to read and analyze to come up with some results. So I would have to keep track. So here's my data table. It's pretty basic. So I roll a die once, I got a 4. And then I roll it again, oh, I got another 4. I roll it a 3rd time, I got a 3 this time. So I'd want to keep track of how many times I roll the die, and then at the end I would tally it up. That's experimental data. That is experimental probability versus theoretical. Because technically theoretical probability for all of these is 1/6, right? But the experimental probability would be the data that I get after I run an experiment. Okay, so hopefully that makes sense to you. So we are going to be using a probability model. Now it's just a simulation, that's all it really is. And when you run your experiment, you're going to keep track with a tally, and then you're going to go ahead and write your probability as a fraction. So if I had done this several times, 50 times, let's say, and I had some data here that we could use. I'm just making up some false data right now. I would really want to make sure that I look at this and I count it and I have the accurate number. But let's say we've got all our tally marks here, and I go to total it up over here on the right side, and this is what, 5, 6, 7 out of 50 rolls. Okay, so then I would take my 7 out of 50 and I would want to write that as a percent. So when you do an experiment 50 times, it's so easy to calculate as a percent because a percent we would use a base of 100. So I would just double this. So this would be 14 out of 100 or 14%. So 14% of my rolls, I got a 1. That's how easy this is. So you guys are going to do an experiment next with your Skittles that I gave you. So we are going to go ahead and answer a few questions together first, and then you guys can actually get started on your experiment. So the first question is asking you, what's the probability of getting a pink Skittle? So you're going to take your bag of Skittles. Now, some of you got little bags like this, and then I ran out. So some of you, instead of getting 2 little bags, I gave you a large bag. So your data might be a little bit different than ours. All right, so theoretically, I have an orange, red, green, purple, yellow, and then the total number of Skittles, right? So theoretically, if you look at your package of Skittles, you've got an orange, red, yellow, green, purple. And I don't know if I'm missing one, but I think that's it. So when we look at question 1, what's the probability of getting a pink Skittle? Notice the notation there for number 1. It's got a P, capital P, and then instead of parentheses and pink in it. That means the probability of. The parentheses just stands for the word of. It's not too big of a deal. So what's the probability of getting a pink? Well, if there are 5 colors, then we would say 5 out of, well, 1 out of 5, right? And I just realized that I have this set up for when I did an Easter experiment, and I did not change this. So, actually, I think I left that there on purpose. So if there are no pink Skittles, 0 out of 5, right? What's the probability of getting a yellow? Well, if there are 5 colors, your probability, theoretical probability of getting a yellow would be 1/5. So what is that as a percent? It's 0.2 is a fraction, so 20%. Now, what's the probability of getting a green or a purple Skittle? So this one's a little bit different. We can count both of those because you could get a green one or you could get a purple one. So there are 2 colors represented out of the 5. So you would write 2/5, or that would be 40%. So hopefully you've got the same as me. 0% for getting a pink Skittle, 20% for getting a yellow Skittle, 40% for getting either a green or a purple. Now it says, is it possible to get a blue and a pink Skittle when you randomly pick one out of a bag? Well, even if we had pink Skittles in here, it's not possible because we don't have any pink Skittles. But each Skittle is its own candy, and so you're not going to get, there are no swirled candies in here. There aren't any mermaid candies. Sorry about that. So the probability would be 0. So no, it's not possible to get 2 different color Skittles when you pull one out. All right, so I hope that makes sense to you. What I want you to do next is to go ahead and read through the instructions, sort your Skittles according to color. You're going to go ahead and record how many of each color Skittle that you have here in your table. And then I want you to calculate the probability, and this would be not theoretical this time. This would be experimental probability. So if this were my package, which I know you guys can't see this, but I got three orange Skittles here. And so the probability of getting an orange one, well, if I had a total, I only opened one package, by the way. Let's see, 12. So I got 3 out of 12. So I would write in my table for orange 3 out of 12, but I also need to figure out what is that as a percentage. So I want you to do both as a fraction and as a percentage. Okay, so when you're all done, go ahead and take a screenshot of this. Actually, I don't even need you to do a screenshot. I am going to have you go ahead and I'm going to share with you a document that I want you to complete, and you can just complete it right in Google Drive. So hopefully that will help. I might